All right, folks, we're going to look at a couple problems dealing with writing equations of an ellipse, right? We've spent some time taking the equation and using it to find information about the graph of an ellipse. Now let's reverse that role and let's write some equations based on the information that we're given. So first problem here, write an equation for an ellipse with a major axis of length 30 and a minor axis of 20. Okay, so let's sketch an ellipse here. Okay, something like this. Now, it didn't tell us the problem here when I gave it to you. It didn't tell us where the center is, which is the major axis, which is the minor axis. So we've got some ability here to just make some decisions. And I'm going to choose the center to be at 0, 0, and I'm going to choose the major axis to be along the x-axis. I think that's going to make it easiest. So the major axis has a length of 30. So from here to there has to be a length of 30. That means this would be at 15, 0, and this would be at negative 15, 0. All right. Minor axis has a length of 20. So from here to there is a length of 20. So that puts us right here at 0, 10 and 0, negative 10 to give that length of 20. All right, so now it's equation time. Now, if these are the major axis, if this is the major axis here, these are the vertices, right? There's a vertex, there's a vertex. And when we think about the equation of an ellipse, we put the a squared, which corresponds to the major axis, on the under the x when it's horizontal. And remember that A tells us where the vertices are. So in this one, it's pretty simple. A is going to be 15, right? That's that unit right there. The major axis always has a length of 2 times A. Okay, so A is 15. The minor axis is always 2 times B. Remember that when we labeled these in the past, we called this 0b and 0 negative b, just like this was a0. This is negative a0. So b in this problem is 10. So a pretty simple problem here. We're going to go x squared over a squared, and when I square 15, I get 225 plus y squared over b squared, and b is 10, so b squared is 100 equals 1. Okay. Now, if you wanted to make the major axis the y-axis and the minor axis the x-axis, you could just switch these two. You could put the 225 underneath the y squared. You could put the 100 underneath the x squared. If you wanted to move it off the center, if you wanted to pick the center to be something else, remember, you could just put an x minus something and a y minus something to do that. Let's look at the next problem. Write the equation of ellipse centered at the origin, symmetric with respect to the x and y axes, has a focus at 4, 0, and has a point on the graph at 0, 3. All right, so this time a little bit more specific. I say I want it centered at the origin, and that the major axes are going to be the x and y axis because of the symmetry. Now, I didn't tell you which one was the major axis, which one's the minor axis, but I think we can figure that out. Okay. Says that we have a focus at the point 4, 0, and we have the point on the graph at 0, 3. All right, so there's our x and y axis, centered at the origin. Those are going to be lines of symmetry. There's a focus at 4, 0. Now that puts it right here. Okay. Now remember that the focus always has to be along the major axis. So if our focus is on the x-axis, our x-axis is going to be our major axis. So we know that the ellipse is going to be, let's see here, I know it's not centered here. Let me just adjust it. There we go, something like that. There we go. Our major axis is the x-axis. Now if a focus is at 4, 0, that means we also have a focus at negative 4, 0. So we've determined that the x-axis is the major axis, which is important. Now where's that other point? Well, a point on the graph is 0, 3. And where's 0, 3? It's right here. So this gives us one of our co-vertices. That's a covertex. Now, remember that our covertex, just like on the last problem, right, this is a covertex there and a covertex there, gives us the value of b. So we know that b equals 3. Now we have the foci here, which gives us another value that we know. The foci correspond to c. c equals 4. Now, what is the relationship between A, B, and C? Because we don't know the coordinates of the vertices. But remember that c squared equals a squared minus b squared. So when we substitute in here, we can say, well, 4 squared equals a squared minus 3 squared. So 16 equals a squared minus 9. 25 by adding 9 on both sides equals a squared. So a is going to be 5. Now I know it's plus or minus, but that puts this point right here at 5, 0 for this vertex. And it puts this vertex at negative 5, 0. And we have our equation as x squared over, now remember major axis is horizontal, so it's going to be a squared underneath the x squared plus y squared over b squared, which would be 9, right? 3 squared is 9 equals 1. There you go. So there's a couple questions there, a couple problems dealing with writing equations of the ellipse. Thanks for watching.